Hello and welcome back to my Advent of Code 2024 solutions in ARM assembly for the Game Boy Advance. We are up to day 2 of the 10 I completed. Let's have a look at today's problem. So we are at a nuclear fusion fission plant for some reason. We have this sort of puzzle input. We have a list of numbers called reports, and they have 5 levels. I don't know how many are in the actual input. Might check that in a second. And we have to determine which reports are safe. So there are 2 rules to determine if they are safe. The first one is that the values are either all increasing or all decreasing, and any 2 adjacent values differ by at least 1 and at the most 3. Right? So we have a look at this one here. The first one is safe because 7, 6, 4, 2, 1 are all decreasing by 1 or 2. This one is unsafe because 2 to 7 is an increase of 5. This one is unsafe because 6 to 2 is a decrease of 4. This one is unsafe because you're increasing 1 to 3, and then 3 to 2 is a decrease. And then this one here is unsafe because you have 2 4s, which is neither a decrease or an increase. And the last one is safe as well. And then of course, for part 2, you've got to see if removing a single bad level will make the report valid, make the report safe. Right? So in this case, the second case, we can't remove anything to make it safe. The third case, we can't remove anything to make it safe. Fourth case, we can remove this 3, and then it becomes all ascending numbers, increasing numbers with the correct spacing. And the fifth one, we can remove one of these 4s, and it becomes safe with all decreasing. So that's what we are doing, and let's have a look at the code, shall we? Goodbye browser. Hello Nevin. Alright, so what have we got here? This time I am completely in the internal RAM. We've got ASCII-num's hanging around for reading in the numbers from the input. We've got a val array and gval array, which will be our lists of numbers in the reports. The starting off the sole day, pretty much the same as before. R8 is the start of our input address, R9 is the end of the input, R10 is going to be our offset, reading the input, and R6 is the mode that we're in, which is either reading numbers, finishing a line, or finishing the input. So then we have our read loop where we're checking if we have reached the end. If we've reached the end, R6 becomes 2 and would branch to convert ASCII. Would read in the value from the input, the byte from the input. If it's 20, it's a space. We need to convert the ASCII number into binary. If it's an end of line, OA, it would change R6 to 1 and convert ASCII as well. And then our convert ASCII routine is the same as before. We AND it with OF to get the binary encoded decimal value. We load the offset from ASCII-num, increment it, store the binary code decimal into that ASCII-num array at the new offset and store the offset back. And then we'll fall into this increase offset for reading from the loop. Now, if we have fallen into this, if we have jumped into this convert ASCII, that's the same as last time as well, right? We've got R1 will be our resulting binary value, R11 is our multiple, starts at 1, R7 is our tens multiple, which we'll be multiplying R11 by for each place in our decimal result. R3, so we load in ASCII num offset, and then we load in the values from ASCII num, we multiply it by our multiple R11, we add it to the result R1, we multiply R11 by R7 and put it back into R11, and we subtract 1 from the offset, and then we loop until we get to the end of the number. Right, and so that gives us the binary output of the decimal input. And then we store that into the val array, same way we're storing into the ASCII num array, load the offset, add 1 to it, store it, and then store the new offset. Now, one thing I've noticed here is that I'm storing byte, which means that the values are all less than 256. The larger, I would have had to have used a half word or a word to do them, but that just tells me that they're all less than 256. It's alright. And then we, at the end of convert ASCII, we have to reset the pointer, the offset for ASCII num, so that we can read in a new number without corrupting or using old data. Then we're comparing R6 to 0. I should have done BEQ inc offset and let it fall into eval line, but instead I've got BNE branch to if it's not equal, branch to eval line, and if it is equal, branch to inc offset. Anyway, so let's say I get to eval line. What happens now? Let's see. So what I do is we load R5 with 1. This is just a flag to tell if the value, if the report is safe or unsafe. It starts out default being safe, and would invalidate that if there's an unsafe status. The next one, R7 is going to hold if it is a safe, if it's increasing or decreasing. Now I should have had this actually as len -1, but that's alright. We'll see how that works before, but basically len -1, so if R7, let's say the length of the report is 5, like the ones in the example, if R7 has the value of 4 or -4, it is safe. If it's not those two values, then it's unsafe. If it's not one of those two values, it's unsafe. That's how it's going to work on that check. There are other checks as well. So next we're going to load in and check each value in the val array. So we load up our value array, we load the first value in first, and we subtract 1 from the pointer. That's fine. And we go into our loop. Then we load the next value into, so that starts off with R0. Then we load the next value into R1, and we compare them. If it's greater, if R1 is greater than R0, no, if R0 is greater than R1, I had to remember the way this works. I think it's if R0 is greater than R1, we add 1 to R7. If it's less than, we subtract 1 from R7. Right? So that's how that R7 is going to work. Right? If in sequence they are all greater than each other, then R7 is going to be added, is going to have 1 added to it 4 times. So it's going to end up as 4. If in sequence they're all less than each other, then it'll have 1 subtracted from it 4 times, and it will end up as -4. The next part, and we're still using this compare here. We're still using it down here. If it's equal, if that compare was equal, R5 is immediately 0. It's immediately an unsafe report. Otherwise, depending on if it's greater than or less than, we'll subtract either R1 from R0 or R0 from R1, put that result in R2, and if deleting lines there, and then we compare R2 with 3, and if it is greater than 3, so if the difference between the two values is greater than 3, then it's unsafe. We invalidate it. Right. Then we move the value that was in R1 into R0. We subtract 1 from the offset, and we go back into the loop. So the next time we'll load a new R1, and we're comparing the next two pairs in the array in the report. So imagine we come out, we've subtracted 1, and it said 0, so we're finished. First thing we're going to do, we're going to compare R5 with 0. If it is 0, it is unsafe, and we'll branch to the unsafe check, which we'll go over a bit later. Next one, we're going to load the length, again the length of that array, the val array, into R3. We're going to subtract 1, and then we will compare it to 0. Now that should never be 0, at least on the inputs we have here, because they on the examples, because they are an odd number of values. It'd have to be an even number of values to get a 0. Anyway, we check it. If it is 0, it's definitely not safe. Branch to the unsafe check. If it's greater than 0, we'll branch to check larger. Otherwise, we go into here. We'll move into R0, the value of 0. We'll subtract R3, so the length of that report, the number of values in the report, minus 1, from 0 to make like negative 4 or whatever it is, and we compare that with R7. If it is not equal, unsafe check. If it is equal, we'll go to add score. It's minus 4, and we made it here without one of those other invalidating checks. And in the check larger one, we just check, we compare R3 with R7. R3 again was the length of it minus 1. And if that is not equal, we'll go to unsafe check. Otherwise it falls into add score. And for add score, we will be adding 1 to both the silver and the gold, part 1 and part 2, if it is a valid result. And then it would branch to finish eval, which is down here. Finish eval, we'll check if R6 is 2. If it is 2, then we have finished, right? We've finished the input, we'll branch to finish day. If it isn't, we need to clear out the value in the pointer, the offset value that's in val array, so store 0 in there, and we also return R6 to 0, right? We push 0 from R2 into R6, and we branch to inc offset to continue reading the input. So next is the unsafe check for gold check, right? Gold, remember, for gold we want to check if we can remove one value and have the report become a valid report, a safe report. So here's our gold check, right? So what we're going to do here is we're going to make a copy of the value array minus one of the numbers, and we're going to try all the mutations of that, right? and check if it becomes if there's a valid result in there. So we val array R10 is going to be our pointer to val array, with R9 being our offset. We will subtract 1 from it and store it in R11. We're going to make we've got to make, because it's going to say how long the array is going to be in gval array. Then we load gval array's address into R12, and we're going to store that R11 into R12 into gval array. Right. So let's say that val array is 5 in length. We're going to take that 5 minus 1, so make it 4, and store that 4 at the beginning of gval array to say this is going to be 4 numbers in length. And that's the offset I'm going to use for copying values in there as well. Don't worry, it works. And then R8 will be the value that we'll skip each time we copy the array. So right now that will be R9, which will be the index of the last number in val array. So that will be skipped the first time we copy val array into gval array. So we have this here, check next check next mutation. This will be a loop. We load byte from we load in the lengths of val array and the length of gval array. And we have this loop here for loop remove, which will actually do the copying. So compare R9 to R8. If they are not equal, then we load the value from val array at R9 index. We store it into gval array at R11 index. We subtract 1 from the R11 index only if it is not equal, and we subtract 1 from R9 regardless of whether it was equal, and we set the flag to check if we are at the end of doing this loop. Right. So the first one, it's going to skip the very first value because R9 will be the same as R8. And later on, we'll be subtracting 1 from R8. We'll be decrementing R8 to get to be skipping a different index each time we copy the array. And then the rest of this is basically the same as before with this part 1. Right, we're using R5 to check if it's safe, R7 to check if it's all increasing or decreasing. There should be -1 on these. Right, and now we're just using gval array instead of val array. Right, and all the rest is the same. Right, we load the values, we start with the first 2 comparisons, right, from the last number and the second to last number, compare them. If they are greater than or less than, we increment or decrement R7, we subtract R0 from R1 or R1 from R0, and compare if they are more than 3 apart. And then we move on to the next, right, to the next one. We keep going through that all the numbers in the array, and then once we get out, if 5 is 0, we go to try next mutation, which will skip another number. We check if they if R7 is 0. Right, straight up 0, then it's not all increasing and all decreasing. We check if the all decreasing is correct, right? If if R7 is equal to negative the length of the array minus 1, right? And if it is, we go to branch gold, or we check if it's equal to the length of the array minus 1, positive, and if it is, we'll fall into add gold. If we get into add gold, it'll increment result 2 for part 2, and then branch out to end gold check. If it was still unsafe, then we would decrement R8. Decrement R8. If R8 gets to 0, then we have finished as well, so it would fall out straight into end gold check. Otherwise, it would branch back up to check next mu, which will copy the array again, skipping the next number, and trying again to check if the list is now safe. And then we have the end goal check here. We exit out of this subroutine. We end up back. Would end up back here, right? And eventually we would finish all the input and get to finish day and go back to waiting for input from the user on the A button. So that's all the code. Let's have a look at it. Let's see this thing run. Here we are. We've got our emulator going. Part 2. And let's run it. And that's the result. It's quite a small result really, not that many numbers. So it takes no time at all to run. Let's have a look also at the memory, shall we? Let's have a look at how it looks in memory. Let's bring that up. There we are, got the memory again. So again, it is updating every frame, the values on there. Our results are sitting over here and sort of spread out across the place. I think we've got an ASCII number sitting up here somewhere. We've got our val array down here, and our gval array like over here or something. Very spread out, not very compact at all. Let's watch it run and then we'll be done for today very quickly. So one more time, 3, 2, 1, bonk. Yep, there we go, and it's done. So it looks like it was about there. It was ASCII num. Alright, so that's day number 2 done. Still very easy. It will get a bit more difficult in the coming days. Alright, I hope to see you again for day number 3. Until next time.